Welcome to an introduction to WAN setup for the Ecessa PowerLink, ShieldLink, ClaraLink, and WANWorks solutions. The purpose of this video is to describe the various WAN configuration options. If you have specific questions about setting up a particular WAN network, as always, I'd encourage you to reach out to our support department, who are always happy to be of service. Setting up a basic WAN connection requires only a few specific values. We begin by pressing the Add New WAN button. We're now presented with a screen where we will first need to provide some basic information. We begin by identifying the type of WAN selected from the drop-down menu. The available types are static, when you know the static IP and subnet mask, DHCP, where the IP information will auto-discover from the ISP, Pppoe, which is a bit legacy but allows you to set up a Pppoe connection, translucent, which routes through addresses essentially as a bridge, routed, which is also a legacy option replaced by translucent mode, and IP version 6 and IP version 4 tunnel, which is similar to a static WAN but requires a tunnel broker at the other end. Note that once we select a WAN type, we are then presented with configuration options specific to your selection. Ethernet port is where you can identify which physical Ethernet port a particular WAN connection should be assigned to. Of course, you can change a WAN to any of the Ethernet ports to suit your needs. Next, we have to create an alias. This can be anything you like, but typically it's enough to designate each WAN simply as WAN 1 or WAN 2, but it might be more useful to name the WANs after the providers to help identify them easily going forward. Note that if you're using a DHCP connection, the WAN IP address, network mask, and gateway router IP should fill in automatically based on the information provided by the ISP. However, items like the alias, uplink and downlink speeds, test point information, and Ethernet port would still be required. For most WAN types, we'll have to assign the WAN IP address. This would be an address within the WAN subnet. It will also be the default IP address used by outgoing traffic from that WAN connection, unless the WAN is configured in routed or translucent mode, or overruled by a static route or one-to-one NAT rule, options which will be covered in subsequent videos. The network mask is used to identify the scope of the network. The router or gateway IP address will identify the default gateway address for that particular WAN connection, typically a gateway router or modem. The test points are how the Ecessa device determines the up or down status of a particular WAN connection. For a public circuit, these test points might simply be servers out on the internet that we're confident will be reliable and responsive. Google servers, Yahoo servers, etc. Note that typically you would not want to use the gateway router address as a test point, as that would only be testing connectivity to the gateway router, and not actual connectivity through the ISP to the internet. If any of the test points respond, the Ecessa device will view the connection as up, because it has connectivity over that connection. However, if none of the test points respond, the device will assume the connection is down and will fail over the traffic accordingly. Using Ecessa's defaults, that failover typically takes about 10 seconds. You can adjust that in a number of ways, and we will cover some of the methods to do so, but we found that in most cases 10 seconds is a good balance between having a timely failover while still avoiding false positives, which might be disruptive. By default, the WAN testing uses ICMP, though you can instead configure a test point to use a TCP handshake using whatever TCP port you prefer. The timeout value is one of the means by which you can adjust the testing sensitivity. You can increase the timeout value from the default of 1 second if, for example, you have a high latency connection and want to allow a little more time for the responses to return. The line testing responses per number of tests section is another way in which you can adjust the WAN line testing sensitivity. The first value indicates the number of valid responses you're expecting, while the second value represents the number of tests. In other words, in this case, as long as we get one positive response out of every 3 tests sent out, we'd view the line as good. The link speed up and down values are used for the default outbound load balancing. The left field is for the uplink speed, the right field for downlink. You can see that's specified in the tooltip as I mouse over the fields. By default, the Ecessa device will measure the speeds of the various connections as entered in here, combined with a view of the amount of traffic currently going over each WAN line to identify, on a per-session basis, which connection has the most available resources. So we might send one session out one line, the next session we might send out the next line, depending on which has the most available resources at the time. This behavior can be overruled. You may have specific types of traffic that you want to, for whatever reason, send out a particular line or set of lines by default, and we can absolutely do that. That can be set up using static routes, which we won't cover here, but which are explained in great detail in a video detailing static route functionality. But again, the default behavior is to intelligently load balance the traffic based on those criteria I mentioned. Now let's take a look at some of the advanced options. MTU can be changed if you're using either VLAN tagging or Pppoe if needed. We also have the ability to set an 802.1q VLAN ID tag for the WAN connection, again if needed. The spare line option allows you to indicate that the WAN is something of a last resort connection. If the spare line checkbox is checked, the WAN will not be utilized for outbound traffic, nor will it accept inbound traffic unless all other options are unavailable. It can also be set to test at a very different interval than that of an actively utilized WAN line. For example, you can configure it to test once an hour rather than every few seconds. This is configured under the Services section, which will be covered in depth in a video specific to that aspect of the configuration. The No Outbound option is something like the spare line option, but it is a bit more versatile. With the No Outbound option, no outbound traffic will be sent out the specified WAN by default. However, unlike the spare line option, it can still be overruled by static routes, and the line will still accept inbound traffic. Disable recovery is rarely used. Essentially, it turns off the WAN line testing, making the connection always be seen as up. This is useful only very rarely, possibly for troubleshooting purposes or a lab environment. If we go back to the top and select the Pppoe option, you'll note that fields appear at the bottom of the configuration to enter the appropriate Pppoe values, including the mask, the username, and the password. Once finished configuring the WAN, be sure to hit Activate to commit those changes. As always, when you're finished, be sure to save your configurations under the Get Set Configuration section and replicate to the idle device, if one is present, under the Hardware Failover Configuration section. There we have it, WAN configuration. For additional information, please don't hesitate to contact our support department, who are always happy to assist.